And we're live. Hello, everybody. Welcome to our final meetup of this year. We're all happy that you're already here back with us. Before we are going to our panelists, we have like a new item that we want to introduce you every time. So, of course, again, welcome. This is the wrong screen. This works better. If you're willing to join us, we're on Angular Discord, we're on Angular Nation, on Slack, ping us and we'll help you. Look at our website. If you need some extra information, you want to provide a talk, you can just email us. Of course, follow us on Angular Dutch. Here we will update you with our latest meetups for next year. We already have some things in process for next year, so wait for that. And a special thing for me, we're at 10 events today with over 1,000 users to our meetup, and that's a highlight for us. We did a lot of things this year due to Corona. We needed to do it online. We're looking to do it with you, together with you, basically. So good things. Hopefully, we can see each other next year. As the last time and the time before, we got still 2 Coca licenses, personal licenses that you can win. Bjorn will take care of that today. So get your chat window open, ask the good questions, and Bjorn will invite you to get this license. So back to our panelists. As always, the famous Bjorn. How are you doing, Bjorn?
Hi, thank you. I'm famous now. I'm so happy to be here. End of the year for me. I'm stoked. Hoping for a way better 2021. But it's been fun. I mean,
yeah, really fun. And Sander, welcome.
Hi. I'm glad to be here. I'm glad it is the last one of the year. After working for 51 weeks in a row, I'm ready for a vacation.
Yeah, I think we're all ready for some holidays, even if it is at home.
Yeah.
So, and our guest panelist, all from Belgium, Frederik, how are you doing? Welcome.
Hi, thanks. I'm happy to be here. Thanks for having me, of course.
Yeah, with pleasure. We've been talking around I think, on the Angular Discord in this case, around your topic, and we connected. And well, here you are to share with us all the things around authorization.
Yes, I'm excited.
Great. Do you want to start with your presentation?
Of course.
Okay,
sure.
let me. I think it's ready, so it's all yours if you want.
All right. Hello, everyone, and welcome to Authorization in Angular. PKCE, I choose you. For some, the title might mean nothing yet, and I hope by the end of this talk, for some of you, and you know what PKCE means, or at least to some degree. We will start with exploring the concepts of securing a single-page applications before diving into combining Angular and Auth0 to implement authorization in a single-page application. My name is Frederik Prijck. I am a software engineer at Auth0. I work on our .NET and JavaScript SDKs, and you can find me on Twitter at the handle mentioned at the bottom of the screen. Don't hesitate to reach out if you have any questions, feedbacks, or concerns. At Auth0, we value your feedback as well. On my slide is a link to a feedback form. After the talk, you are free to fill in the form. It's not required, but if you do so, you fill in your name and your email address. We will reach out and you will get a link where you can choose to get a t-shirt or a mug. So it's for everyone that fills in the form. It's not that we pick one or anything. So please provide feedback so we can improve the talk. And if I give it once more, that it's even better than it will be today. So authorization in Angular, or authorization in general, OAuth. OAuth is an industry standard protocol for authorization that describes how clients and servers can have authenticated communication without sharing actual credentials. So basically, we are only providing our username and password once, and we will use a token, often it will be a JSON web token, to prove our identity throughout the rest of our application. OAuth defines a set of authorization flows that we can use, in different types of applications. This definition of OAuth might not make a lot of sense, so I will try to explain it in my own words. And basically, it means that we are going to give an application permissions to access another system on behalf of a user without sharing your credentials. So we are talking about authorization and not authentication, right? Of course, both are necessary in order to log into an Angular application or an application in general, but OAuth itself only concerns about the authorization part, like giving permissions to an application. The access is granted using access tokens. It's a token that gives you access to a system. The idea of OAuth actually originated from the fact that if you go back before OAuth and you had an application where you needed, let's say you have an application and you want to integrate Google and you want to show the user's contacts list. Previously, you probably asked for the user's username and password, save that in your system, and use that to query Google. This basically means that you can now access the contacts list, show it in your application, and the user is satisfied. However, with the username and password, you can access anything. So that's actually not a secure way to give a certain application permissions to access another system on your behalf. And this is where OAuth comes into play. As I mentioned, OAuth defines multiple flows depending on the application type. That is single-page applications, web applications, native applications, and I'll cover some of those flows throughout this talk. Before we begin, there is some terminology that I want to go over because I'm using some words throughout the slides that might mean nothing to you yet, and I want to clarify those first. So there's a concept of a client ID, and a client ID is actually an identifier for the client that is used to access the systems on your behalf. It's nothing secret. It's something that can be public. It's just an identifier of the client that we are using. But there's also the client secret in some situations. This won't count for a single page application, but more on that later. But there's also the client secret, which is actually something to prove that you can actually interact with the identity provider of choice. And then there is also the redirect URL. The redirect URL is actually a URL to which the identity provider should redirect you after authorization. Because we will be using redirect flows, we're basically going to leave our single page application, go to our identity provider, and eventually come back to our own application. And for that, the authorization server needs to know a redirect URL to which the user should be pointed back when authentication and authorization was successful. Before we dive into securing single-page applications, I want to have a look at how traditional server-based web applications handle authentication and authorization. Because server-based web apps have access to the server session, securing them is a little bit less complex than securing single-page applications. However, securing single-page applications basically use a comparable flow as server-based web apps. So I think it's advised to start with this flow in order to understand the flow used for single-page applications. Server-side web applications use something called the authorization code flow. And it's actually a flow where after you enter your credentials, you will get an authorization code. The code will then be used together with the client ID and the client secret to exchange a token. So the user enters their credentials on the identity provider, you will be redirected back, you will have a code, and then you can exchange the code. To show the flow in more detail how it works, it's important to know there are three important parties. There's the user in the browser, there is the server-side web application, and there's the authorization server, which ideally lives on a different domain. Everything starts with the user that initiates the login. Could be a button click, opening the application on a secure route, or anything that triggers the fact that you want to log into your application. The server-side web application, after clicking the login button, for example, redirects the user or the browser to the authorized endpoint on your identity provider. In that request, we will include the client ID and the client secret, as well as the redirect URL. So in this case, we are using the client secret because everything is happening on the server. Because the client secret is stored on the server, so it's fine to include that as part of your request. Then you end up on your authorization server. You authorize the application to access the system on your behalf. Of course, you have to authenticate first. After authentication, you have to authorize the application, and then you will be redirected back. Inside the URL of the redirect URL will now live an authorization code, which will be captured in your server-side web application to then use to execute another request, in this case, a post call to the token endpoint on the authorization server. In this call, we include the client ID and the client secret together with the authorization code. And then the authorization server will return a token. So there are two important requests involved in this flow. There's first the authorization, the authorize call, which is an HTTP GET, or actually a redirect, which is HTTP GET to the authorization server. And there's the token call to actually retrieve the token. So those are the two important calls of the authorization code flow. And there's one important thing to mention, that in the authorize request that I have in step 2, you should not include the client secret. It's a mistake on my slide, forgive me. The client secret has to be secret, so it should not be part of your URL, obviously. So when you go to the authorized endpoint, only include the client ID and the redirect URL, obviously not the client secret, else it's not a secret anymore. So my mistake. But this is how the authorization code flow works. 2 requests, you get an authorization code, and you exchange that code and retrieve a token. And then you can use that token, and you can store the token on your server in your session, and you can communicate the session ID to your client, to your application, to your browser using a cookie. That's how it works. An important part to know about authorization code flow, or the fact that it's using cookies, is that cookies are subject to cross-site request forgery. Basically, it means that if you use this approach and you're having a cookie, a malicious site can include a form on their own site that basically does a post request to your own domain, in this case, yourapp.com. And if you're already having a cookie for that domain, the cookie will be included in this request, right? So that's actually a problem. However, that doesn't mean we shouldn't use that flow, because there are things we can do to prevent CSRF, right? You can include a CSRF token, which is actually a random value that gets generated on your server and gets inserted in your form and sent back to the server, right? That way the server can validate that the post request that's happening is actually happening from a form that is rendered on your own server, instead of a malicious site that's using their own form. That's one way. Or you can use something called same-site cookies. Same-site cookies are cookies that are only sent to the same domain. So if a malicious site from domain A would have a form doing a post request to domain B, the cookies from domain B will not be included. So then that's a secure way to handle that. So this was a little bit of side information around authorization code flow before we dive into actual single-page applications.
Yeah. Small question, Frederik. The same site cookie, is it if you like add that to your web application, let's call it like that, it will already help you with the malicious stuff, right? That's basically how the concept works. Just add the cookie, use it with the same site principles that are probably everywhere documented, and it will just assist you. Not with the authorization, but
yes, it will just ensure that the cookie is not sent in requests that happen from other domains. So,
can you clarify? Can you clarify for me real quick? Like, from technical terms, are we talking about like HTTP only?
No.
Is that the main mark that you're looking for?
HTTP
are there
only
other
is
marks
actually
we're looking
the thing
for?
that says that you cannot access your cookies from your JavaScript, right? And same site basically tells that it only involves is only sent as the same domain.
Great, yeah.
I am not a cookie expert, but I think it are 2 different flags. If someone knows on YouTube, let it know in the comments. But I think it are 2 different flags, because you have like same site lags, same site nom. There are different values for that, where HTTP only is mostly just it is or it's not HTTP only. So,
but you like cookies, right?
Yes, for sure.
Okay, sure, continue. Thank you.
A little bit side info on server-side web applications, but of course, we are here for single-page applications, more specifically Angular. But the majority of the talk actually works for Vue, React, or anything that runs in the client. Important to know is when using single-page web applications, we don't have the typical sessions. We don't have a way to store a secret because a secret obviously has to be secret. So you don't want to store that in your JavaScript, in your browser, because anyone can access that. So we actually need a different way to handle retrieving a token, right? Luckily, OAuth provides us with different flows that we can use for doing this. One of those flows is called the implicit flow. The implicit flow is actually being discouraged by security best practices. I added the link on the bottom of my slide for anyone that's interested to read a specification document around the subject. But basically, after entering your credentials in the first step, the authorize flow, you will retrieve a token as part of the URL in your redirect URL. So not an authorization code, but a token. The flow works like this. So again, you have three parties. You have the user and the browser. This time you have a client-side web app, and you still have your authorization server. The first part is the same. So user logs in. You do a redirect to the authorized endpoint using client ID and redirect URL. Nothing different from the authorization code, other than the fact that you have to specify a few more properties in your request that identify the fact that you want to use the implicit flow. I don't want to go into too much technical details. So you basically tell to the authorization server with some kind of value in the URL, I want to use the implicit flow, and the authorization server will know. Again, you enter your credentials if you're not authenticated yet with the identity provider. If you all are ready, that step will be skipped, but then you will authorize the application again to access the data on your behalf. And when authorization has been successful, when you give the application the permissions to access the data, the authorization server will redirect back to your application and include the token in your URL, which is super easy, super straightforward, right? However, as I mentioned, it's being discouraged because the token is included in the URL. And the token being included in the URL means it is extremely vulnerable to cross-site scripting. It's part of your browser's history. JavaScript can access your browser's history, and tokens can be stolen, right? So imagine having access tokens in your URL. It's easy to get them, right? Also, it's a client-side web application. Browsers, client-side applications are generally less secure than server-side web applications because it runs on the browser. It's harder to trust. So to me, it makes no sense to use a more simpler flow than on server-side web applications. So I wasn't surprised when this flow was being discouraged, even though this is the most used flow for single-page applications today, I think. However, there is a solution for this, and it's called the authorization code flow with proof key for code exchange, also called PKCE. So it's called PKCE, but it's pronounced PKCE. It's a more complicated version of the authorization code flow. Conceptually, it'll be the same, but the fact that we don't have a client secret means that we have to work around the fact that we don't have that secret. Not having a secret means that with PKCE, we are going to include something that's called a code verifier and a code challenge. A code verifier is a randomly generated string on the client side in your browser. So in your JavaScript, you just generate a random string. I don't care what it is. It can be Jeffrey, to pick a random name. And then you can create a code challenge, which is a hashed version, for example, using SHA-256. And that'll be the code challenge, right? So we have an unhashed and a hashed version of the same value. Then we are going to use those two values to send. One will be sent to the first request. The code challenge, which is the hashed value, will be sent to the authorized request, together with the mention of the hashing algorithm that was used. And in the second request, we will send the code verifier, which is the unhashed version. In the second request, the authorization server can compare both of the values and know whether or not it's the correct value. And then without having a secret, we know that we can trust the person that is executing both of these calls. And we know that the one that's asking for a token was the same user or browser or application that was authorizing the actual request. Of course, there is also an authorization code involved, just as with the initial step. So we also get an authorization code back. Again, I have an example on how the flow works. Again, it starts the same. Your user initializes the login. The client-side web application redirects your user to the authorized endpoint. This time it'll include the client ID, the code challenge, and the redirect URL. So the code challenge is the hashed version that was generated on the client side. Then again, if you need, you enter your credentials. If not, there is no need to enter your credentials, but you authorize the application to access the system on your behalf. You redirect back to the application or to the redirect URL that was specified, and you include the authorization, including the authorization code. So now your application has an authorization code available, and it will send that authorization code to the identity provider together with the code verifier. In this case, an HTTP post to the token endpoint. So because of the authorization code, the authorization server now knows how to match the two requests and how to verify that the hashed version is the same as the unhashed version. And then the authorization server returns a token. So conceptually, it's the same as the authorization code flow, with the difference that we don't have a client secret and we have to work around the fact that we don't have one. And this is what we call the authorization code flow with proof key for code exchange. So we need a key to prove to use code exchange. That's where the name comes from. And that's actually an interesting flow. So at this moment in time, we have our application. We have a token in our application, an access token, and we can start using that access token to access APIs, to get data from an API, to get data from external systems, our own API, whatever we want, as long as the token has been issued for that specific API, right? So whenever you are asking for a token, you also have to specify which API am I willing to access, right? Because you are giving a user or an application permissions to access a system on your behalf. The question is, of course, which system, right? So that's also part of the request, which we will see later in the demo. But then again, we have a token in our application. An access token, eventually it will expire, right? Because an access token should not be long-lived. It shouldn't be available to use for days or whatever. So eventually it'll be expiring, and we will need to request a new token. Requesting a new token can be done on two ways. Well, I would say one way, but today there are still two ways, but there's one recommended way. And it's using something called a silent refresh using a refresh token. So until now, the token that I've talked about was access token. But if you want, you can start using refresh tokens. On identity providers such as Auth0, for example, you can enable using refresh tokens, which I'll show later. And suddenly, the call to the token endpoint will start issuing both access tokens and refresh tokens. Whenever your access token is expired, you can use your refresh tokens to do another call to that same token endpoint. But now, instead of providing an authorization code, you will provide your refresh token. And the authorization server will, if the token is still valid, return you a new access token, which is pretty nice. And now you can have another access token that is valid for another, let's say, 2 hours, and you can keep using it. And after 2 hours, the same will happen again, right? But there is a security issue when it comes to single-page applications. When we talk about refresh tokens, the concept of rotating versus non-rotating refresh tokens. A rotating refresh token means that whenever you use a refresh token is invalidated. It means you can only use it once. If you use non-rotating ones, it means that it's valid until it's expired. Because we are in a browser environment, which is always less secure than on a server, it's required. Well, it's recommended to use a rotating refresh token, so that whenever I use one, so whenever I do a call to the token endpoint, I will retrieve a new access token, but also a new refresh token, and then I can use those two again. And whenever the access token expires, I use my new refresh token for doing the same purpose, for refreshing that expired access token once again.
Can I ask you a question here? Because when you're talking about rotating refresh tokens, yes, you're saying they're one-time use only, but the non-rotating, they expire, right? but I'm just assuming that the refresh tokens that are rotating will also have an expiration date.
Yes, yes, sorry, yep. So both will expire.
Exactly, yeah.
Yes, because if you haven't used it for a long time, it'll still eventually expire. But most often, refresh tokens will not hit their expiration time because they will be used. But obviously, yes, they will expire. Sorry for the confusion. But both of them will expire, but a non-rotating will not be invalidated. Means if I steal your refresh token, I can keep using it. While if I steal your rotating refresh token, I have to use it before you use it. And once I have used it, you will get a message when you try to use yours that you cannot use yours anymore. So then you can go in your application, revoke all refresh tokens that you have, whatever, change anything that you think you should do.
Exactly. Yeah.
To avoid any future attacks. So
thank you so much. Yeah.
But there's another concept. There's a silent refresh using iframes. So if you think about the authorization code flow with PKCE that I just mentioned, it involves a redirect to the authorized endpoint and an HTTP post to the token endpoint. The silent refresh using iframes will actually do the exact same flow, but in a hidden iframe. So it will inject an iframe in your page. It will set the iframe to the authorized URL using the exact same arguments that we had in our flow that I've explained. And if you are then authenticated with Auth0 or with your identity provider, because the identity provider relies on their own session. So if you enter your credentials in your identity provider and you come back after 20 minutes, normally you are still authenticated. So if you are still authenticated in this case, it will automatically redirect back to your redirect URL. And in that case, the iframe has done its job. It's redirected to the authorization server and it has redirected back with an authorization code. Then we can do some magic, well, not really magic, but we can do some JavaScript to send that authorization code to our application and then just use that authorization code to get an access token using the normal token endpoint and an authorization code. So this used to be actually a very neat approach, in my opinion, but there is a problem using this approach, and that's Safari and Intelligent Tracking Prevention, or ITP2, which basically says that it's not going to include third-party cookies as part of your request. So if you're running in an iframe, we are actually going to another domain than the application is running, right? So my application is running on angler.com, and in my iframe, I'm going to your identity provider of choice, which is a different domain. And in Safari, because of ITP2, the session or the cookie that matches that session will not be included, and you will always be not authenticated. And then the iframe approach cannot do anything because it needs your credentials, but the iframe is hidden, so it fails. So iframe approach is unusable with Safari. And probably in the future, other browsers will also start doing measurements against ITP2, against third-party cookies. ITP2 is a name Safari uses, because the main idea of ITP2 is to prevent against ads and all those kind of things. You want to avoid iframes in your application that you're using cookies and sending it as part of your, when you use your application without you knowing. And that's what ITP2 is solving, but it's also breaking the iframe approach. So probably in the future, we might be moving away from the iframe approach. Up until now, it's still usable for applications that are not supporting Safari. If you need to support Safari, you can use refresh tokens. Well, that's a weird way to word it. I would always prefer refresh tokens. But again, if you want to use the iframe approach, it's possible if you don't support Safari. All right. Probably the most interesting conversation to have is token storage, right? We have a token, but where should I store this goddamn token, right? There are several blog posts around this thing. There are a lot of Twitter threads that you can read about where you should or should not store it. I would argue you should try to keep everything in memory. So if you get an access token, you get a refresh token, keep everything inside your memory, right? But the question that then rises, if I say that, well, first of all, why do I say in memory? If you don't put anything somewhere else, local storage or whatever, it's harder to steal. It's JavaScript, it's the browser. I can still XSS your application and try to get tokens from your JavaScript, but there are ways to work around that and make it unaccessible, or at least harder to access anything in your JavaScript. So keeping it in memory is probably the most secure way, almost the most secure way. More on that later. But what if the user closes their browsers and comes back at a later moment in time, right? If you would keep everything in memory, and if I open my application, I redirect to the identity provider, I come back, I get a token, I use your application because I have a token in memory, and then I hit refresh. What will happen then is, in case that I refresh a protected route, my application will just redirect to the identity provider, redirect back, and I continue using your application, and the user probably won't even notice that the redirect has occurred because I was already authenticated with the authorization server. Important here is that this relies on the fact that I'm still authenticated with the identity provider. If I'm not, I will be asked for credentials. But this is, if you only store it in memory, it is possible to remember the user after a page refresh.
I guess it also relies on having your application rehydrate the initial state you were building before the redirect, right? So that this is something you have to really do in your own application.
Yeah. Well, yes. In our case, well, I'll show that later as well. But in our case, our SDK that we have from Auth0 does that for you. So it will remember the route that you are trying to execute that is protected. It will store that it depends. In the session storage by default, you can opt in for cookies.
Oh, right. That's cool. Yeah.
Yeah. And then we know where you can put anything in there that you want to, but by default, we store the return to URL is what we call it. And then when we redirect back, we basically redirect back to that route.
And still the application you're building has to respect these rules, but that's easily implementable.
Exactly.
Yeah. All right. Yeah. Cool. Thank you. Yeah.
Yes. So important to know, there's also the concept of local storage, right? But I wanna before I talk about local storage, I wanna explain the difference between, or the fact that we have a session with our identity provider and that we have a refresh token lifetime, right? So a session with if we are using a redirect, if we refresh our application, we direct to our authorization server, we rely, as I said, on the session with our identity provider, which can expire, right? And if we rely on a refresh token lifetime can also expire. But as I mentioned, if you refresh your access token, you get a new refresh token. So suddenly your refresh token has a new expiration date. So you can keep expanding your refresh token lifetime because you are asking for new refresh tokens. If you don't want to rely on the Auth0 session, the fact that you are still authenticated with your identity provider, you can use, if you don't want to rely on that, you can use refresh tokens, right? And then you can depend on the refresh token lifetime. But if you refresh your application, you lost your refresh token. So in that case, you have to store the refresh token somewhere that you can get it again after the page refresh, which ends up in local storage, right? If I refresh my page and I don't have a session with my identity provider anymore, but I still have a valid refresh token, I can still get a token because there is no relation between the expiration of a refresh token and the availability of an active session with your identity provider. Those two are separate. Once an identity provider issues a refresh token, it is valid until the expiration date or until it is invalidated because it's already been used. It does not rely on the Auth0 set on the identity provider session, right? So an important question to ask yourself is here: is it fine for my application to rely on the session with the identity provider and probably result in a shorter duration that the user is asked for their credentials again? Or do I want to provide a solution where I have the most amount of time that the user can use the application without re-authenticating? And if you need that last one, you should store them in local storage, right? But storing in local storage sounds like a security issue, right? But then there's a concept of rotating versus non-rotating. If you are storing non-rotating refresh tokens in local storage, that is definitely a problem, right? Because if you steal those, I can do a lot of things. With rotating ones, it is a little bit more secure, right? I will never claim that it's secure. Local storage can be XSS, and yeah, then you lost your refresh token. But if it's rotating, eventually you probably will know. If I log into your application, close it, and never use it again, but my refresh token has already been stolen, I'll never know. So there are still issues, but it's safer, and it's better than using non-rotating ones. But again, it depends on your use case. You can go pretty far with just storing them in memory, and I'll show that later in the demo as well. But of course, what about cookies? Most secure way is storing your tokens in cookies. That's the best, right? Then you can have HTTP only cookies, as was mentioned before by Bjorn, and then you can never access your cookie using JavaScript. But that is not possible in all single-page applications, because that depends on the fact that the identity provider that is issuing that cookie lives on the same domain as your single-page application. If you can do that, you probably want to do that, because that is the most secure way. But again, not all single-page applications can rely on that fact. So that's the idea of where you should be storing your tokens. But again, if you use our SDK that we handle all of the storage for you. And we are Auth0. We are an identity provider, one of the available identity providers, and we have SDKs in several languages and frameworks. And one of them, which I work on, is the Auth0 Angular SDK. So I've mentioned a lot of theory around all the concepts, the flows, and all those kind of things. And now I want to show you an Angular application that basically demonstrates how all of this works in an actual application. So now I have to find my browser. I'm sorry. Yes.
Yeah, no worries. Take your time.
All right. So before diving into the code, I just want to show you what the application is doing. So that we
could you bump up the font a little bit? Yeah, I think something like this is maybe once bigger. Yeah, this is better. Yeah, thank you.
Cool. So I have the application. I'm not authenticated. I have a login button. I'm going to open my network tab to inspect that later on. And now when I click the login button, you will see that I am redirected to my identity provider, Auth0 in this case. I am asked for my credentials, which is the first step. The first step, as I mentioned, the talk is mostly about authorization, but of course there's always authentication involved, which is mostly, in this case, OpenID Connect. I don't want to go into details about OpenID Connect, but of course I have to provide some credentials. In this case, I will authenticate using Google, and I am back at my application, and I am authenticated. You can see my image from my profile and my Auth0 dashboard. You can see my information, which is all pretty cool. And then we have the network calls that are happening that I want to explain, that I've just mentioned in the slides. The first one is the authorized call that is happening, right? So the authorized call is the first one that is happening, and that involves some arguments that I mentioned. I'm sorry, query string. So these are the arguments that we are sending to the authorized endpoint, right? We are sending a redirect URI, as I mentioned, which is just my localhost 4200, my client ID. I'm sending my audience. So I haven't mentioned the audience yet. The audience is actually telling my identity provider for what system or what API I want to get a token. Because a token is scoped to a specific audience. Audience is a term we use at Auth0, but you'd have to scope your token for a specific system. In this case, my system is called test. Then you have to provide the scopes. The scopes are actually things that should be included in your access, in your tokens. This is OpenID. It's part of OpenID Connect. Again, not part of the talk. The fact that I want to include some profile information, my email, and the fact that I want to use refresh tokens. I'm going to explain the code afterwards, but I did not intend to use refresh tokens initially. So let me just...
Careful, you made a spelling error there. Oh, I thought it was an I in front. Sorry,
But
my bad.
Continue. So ignore the last 2 minutes for a second, and I'm going to redo this exact same thing so that I'm not having refresh tokens, because that's what I wanted to start with. So, all right, back at my application. So let's go to the authorize call. All right. So now the offline access is gone in the scopes. Offline access is for telling to the identity provider, I want to have a refresh token as well. So here we are saying that we are doing the code flow, authorization code flow, and I want to get my response back, my code back in the query string. This is a little bit too much detail, but I just want to go over the actual calls that I've just explained. There's some state and some nonce that we use. State is actually something you can send to the identity provider, and it will send it back to you. You can remember state across your redirect as well if you want to. Then there is the code challenge that I've mentioned, right? So this is the actual hashed version of whatever random string that was sent, the algorithm that was used, and this is something we use internally. So this is the first request that is happening, and you will see that the response that I have to see is in the response headers, because it will set a location. All right, so you'll see that the location now includes a code somewhere, doesn't it? This is weird. This is not the URL that I would expect. Response headers.
It's always nice in a live demo, right?
Yeah. Let me try that again. Oh yeah, I was inspecting the no. Hang on. This is weird.
Yeah, you wouldn't expect a different one.
Wouldn't be a live demo if something didn't go wrong. Right?
Yeah. I would expect a different URL with the code in the URL. So something is not going as I expected.
Sounds like a typical classic version of clear the cache and try again.
I'm going to try that, but let me try it again. Hey.
Yeah, sure thing. Don't worry, man.
It's
part of the live demo. Part of the live demo. Part of it.
Exactly. Why am I even? Yeah. Why am I even authenticated? It's not supposed to happen. Authentication and authorization is a complex subject, as you can see.
Absolutely. It's absolutely one of the most complex things I've ever talked about or ever heard about, even.
All right. Try again.
Here we go.
It's messing with me.
Okay. Well, could it be that you asked different scopes, for example?
No.
Okay. Maybe Auth0 updated the server.
Yes, probably.
Right.
Well, it's telling me a redirect, and it's redirecting to /u/login. Let me try logging in with a different user. Oh my God.
As you said earlier, Frederik, continue, don't worry about it. But authorization and authentication is a very, very tricky subject. So doing this live is honestly, in my mind, beyond.
Yeah,
it's beyond.
Yeah, it's crazy.
It's beyond. Yeah.
Yeah. Well, the thing is that that this should just work. All right. That is very weird. Is it even /token? I am executing a token call, and the token call has the code. So
Yeah, it's probably something simple. You're misconfigured or...
So here is the actual call that is happening. So I cannot find the actual redirect. So normally I do a request to /authorize, and authorize will redirect. Oh, so this is the one that I have. I think it's because, interesting. Okay, so there is another redirect happening on Auth0. I work there, I should know, but hey. So you do a request to /authorize, apparently it redirects to /login, and then that /login redirects to this URL. That's the one I was looking for, which is my Angular application, including a code in the URL. So AEX is my code, and that's the end of the first call, right? So the fact that there's an extra redirect happening doesn't really matter for the consuming application. The goal is that you end up on your local host 4200 or whatever you sent as a redirect URI to your authorized endpoint with a code in the URL. The next call that then happens is to the token endpoint, right? Because now I only have an authorization code and I'm actually on a URL that has this in the URL bar. Then I have a token call, which is the second call that I've explained. And there we are sending the following properties. The same client ID, now the code that I've retrieved from the authorized server, and the code verifier, which is in this case the unhashed version that I've mentioned before. And in this case, also the grant type. The grant type means telling to the identity provider what I'm sending. Because the token endpoints also accepts refresh tokens and things like that, I have to tell to the authorization server what I'm sending. In this case, I'm sending an authorization code. And the redirect URI, right? So basically you have to, the redirect URI is not used to redirect or anything. It's basically a kind of way to validate as well that it's the same redirect URI. The specification mentions that the redirect you send to the first request have to be the same as the second request, but it's not actually used to redirect anywhere. But the response of this is an access token, right? An access token that we can now use to access systems, or in this case, the system with the audience test, using this access token. There's also in the response an ID token, which is not really part of this request. The ID token is part of OpenID Connect, and it's more concerned about who I am, and access token is about what systems I can access. So ID token is more closer to authentication and your profile information, and access token more about I can access this specific system. So when your application is using multiple APIs to access, you probably have one user and multiple access tokens, probably. So one ID token, multiple access tokens. You have to request access tokens. If you need 4 access tokens, you need to do 4 requests to the token endpoint. But eventually, ID token is bound to your user. Access token is for the system that you're accessing. So these are the 2 calls that are happening. So if I would now, in this case, I have an external API, I can ping it. And then we can see that your access token was successfully validated. And we can see that the access token will be part of the request headers in this case. So this is the exact same value that we just retrieved. So now everything works as expected. I have an access token and I can basically keep pinging this external API with the same access token. All right. Refreshing my page. I'm not using refresh tokens. I'm not using a local storage. And still, I am authenticated. So this is the thing that in memory you can get pretty far. But of course, as I mentioned, if you refresh, you will see that there is a redirect happening. This is not the iframe thing I've mentioned. This is the actual redirect. So whenever I refresh, the user don't really notice it, but it's actually going to Auth0 in this case and coming back real fast, which is actually fine for most applications, right? So first thing, if you don't need local storage, you can remember the user on page refreshes if you have to. So that's what the application is doing. There's nothing really more fancy other than some information of myself and the fact to retrieve a new token. So I'm not using refresh tokens, but I want to get a new token, right? So in this case, I'm going to click, breakpoints. I've clicked the button and you see there are 2 requests happening. In this case, in an iframe. But again, they are the exact same requests. It's an authorized request and a token request. And if you would look at the payload, they look exactly the same. with the fact that in this case, it's the response mode is a web message. It's not query, a little bit different. This is something that's happening in the iframe. The iframe needs to send a message to the token. And the response, as you can see, oh no, does it do? No, it doesn't do a redirect in this case. Right, correct. It's using web message. I just mentioned that. So both calls happening, not entirely identical, conceptually identical, and then the token endpoint to send the code verifier, grant type authorization code, and again, I get a new access token. I can keep hitting this, and I can keep getting tokens, nothing really fancy. Before diving into the actual code, I want to use refresh token. Then I'll explain the code, how you configure the SDK. So interesting, refresh the application, and immediately I'm at the authorization server. But now I'm actually blocked. Well, blocked, not really blocked, but I'm asked for consent on the identity provider. The identity provider asks me if I allow the application to access the mentioned data on my behalf. So this application I'm using wants to use my profile information and allow offline access, which actually means using refresh tokens, which means the application can keep using your data when you don't have a session with the authorization server. I can accept that or decline that, but obviously I want to accept that. You see the URL now. It's gone now, but the code was in the URL in this case, and now I have a refresh token. So if I would go to my token call in this case, you would see that I am now doing the exact same kind of request, code verifier, grant type authorization code, but the response, it's this one, the response has a refresh token now. That's the only difference. So the authorization server does that for you. I have it now, and I store it in memory, right? The consequence of storing it in memory is, of course, if I refresh that, I again have that I don't have an authorized call anymore. Because I do have an authorized call because I'm not storing any local storage. So because it's in memory, I refresh the page, I lose the refresh token, I need to redirect again to the authorization server. So one extra thing I want to add is use local storage. Now I use refresh tokens and local storage, right? So you'll see that we have this nice thing here in local storage. Cool. So if I would now refresh my application, if I refresh my application, it doesn't do any call because the token is still valid. Both access token and refresh tokens are still valid. There's nothing we need from the authorization server. So let's imagine my access token is expired. So I'm basically now messing with local storage and setting the expires at 1. So my access token is not valid anymore. This is not what you want to do. But if I now refresh my application, you will see what happens when a user comes back without having an access token, but still having a refresh token. In this case, the only call we have is the token call. So there's no redirect involved anymore. So there is no relying on the authorization server's session anymore, right? And now we can keep using our access and refresh tokens, but it's important to notice is the token call that happened now is different. It's not using authorization code anymore, it's using a refresh token. So we don't have an authorization code, we now have a refresh token, and we are basically setting the grant type to refresh token, and we are sending the refresh token along the request. And the response is a new access token, an ID token, and a new refresh token, because the application is using refresh tokens. So that's what's happening. Those are the different kinds of flow that I've explained in theory first, that you can now see happening in your Angular application, and that you can hopefully a little bit better understand what's happening, why they are happening. Sorry.
Yeah. Yeah, no, definitely. It's a great example, and especially how you explain all the different flows and how it works together.
All right. How do you get this in your Angular application, right? I wasn't into a real live demo because it even goes wrong when you're not live coding, as you can see. So I wanted to walk you through the steps needed to integrate or Auth0 Angular SDK in your Angular application. Everything starts in Angular with importing a module, right? So we have the auth module that you can import from Angular Auth0/Auth0 Angular, and you need to provide some settings. First of all, there is the Auth0 domain. After the code, I will show you the Auth0 dashboard as well to show you where these values come from. But my account on Auth0 has a domain, right? So that is basically the URL to my Auth0 account. Then client ID, that's the identifier for the application I'm using. Again, this is nothing secret. This is just so that the identity provider knows what the application is. The redirect URL to the actual URI that the authorization server should redirect to go to show you what this looks like. It's not server-side render proof, it's window.location.origin in this case, but I mean, you are responsible for specifying the redirect URI. So if you need server-side rendering, you have to work around not using window. But in this case, I'm using window.location.origin, which basically means, in this case, redirect back to the root of the application. As I mentioned, I didn't show that, but let me show you real quick. If I'm on profile and I refresh, I'll end up on profile. Let me clear this one to make sure. If I refresh the application, I'll end up on profile again, which is because of the app, the state that we store in a session storage, but that's a bit harder to show because that's getting cleared after we are back. So it only exists during the transaction that we are going to the identity provider. But we are now back on the profile. So even though the authorization server redirects back to window.location.origin, our application itself redirects back to the route that we are trying to access. So that's the redirect URI. Then we have to specify the audience. The audience is the API that we are trying to access. So in this case, it was test, which I'll also show in the Auth0 dashboard. Then there's the concept of HTTP interceptor, right? The Auth0 SDK also has an interceptor that you can use, and the interceptor needs to be configured to tell to the SDK which calls we should intercept. And in this case, the interceptor has an allow list property that you can set to an array of strings to match your request. So in this case, I'm saying anything that matches the API URL, and the API URL can be seen in our here, API URL, which is a server I'm running locally, which is not really important in this case. But anything that matches that URL, you should intercept and attach the token to it. So if I'm doing calls to other endpoints now, it won't add the token to that URL, to that request, which is what we want. We only want to send our token to systems that we want to use our token for, not any other. Right? And by doing this, our interceptor will be configured. And then, yeah, you can mention if you want to use refresh tokens, you can mention the cache location strategy. By default, we don't use refresh tokens, and by default, we don't use local storage. So if you want to use both of them, you have to enable them. By default, we use, what are the options? We use memory. So that's importing the module and configuring the module. So we now have most of the things that you have seen throughout the different requests. They are configured and ready to use. But of course, in our case, you still have to import the interceptor yourself so that you want to explicitly use the interceptor. If you don't want to use that, you can opt out of that interceptor. It's not part of our module. You can import it and provide it yourself if you need to use that one. So that's that. That's all you have to do in your module file. So the import, the configuration, and the interceptor. But there's also the routing. Right? So we have a guard available in our SDK called the auth guard that you can add to different routes that you want to be protected. You want to have protected. Nothing fancy, but this is going to ensure that you can only activate that route if you are having access to the given route. Right? This is not doing any role-based stuff for now. Could be something we add in the future, but it's an easy guard. So if you have a strict need for that, it's not that hard to implement. The code is open source, but we might need that eventually. So that is the guard that you need to configure to ensure that if you hit a route that is protected, as you saw, it'll redirect you and it will end up back at the given URL that you are trying to access. A few small things that are worth mentioning in our application is we have an auth service in the SDK. that exposes a user observable that has the information of the user. So you just subscribe to that observable and you get the information that is available for the user, the information that you have requested, but also the information that the user have given consent to in the pop-up that you get to read, right? So we were asking to read the email and the profile, which is why you saw all this information in here, right? If I wouldn't ask for the profile, I wouldn't get the profile, which is just to... Yeah, I don't have that call anymore. But I hope you remember the fact that we had scope, open ID, profile, email, which basically ensures that we retrieve the values for the user. In this case, I just had a button to refresh the token, which is a method called get access token silently, which does the refreshing of the token silently, either an iframe or a refresh token. And in this case, I want to ignore the cache, but that's not something super important. But you can bypass the cache if you want to. Right, we cache the tokens for you. If you call this method and you have a token, we won't do a call for you. From another small thing that we have, the most important stuff has been mentioned, is the fact that if you want to call login, so you have a login button, you click it, all you have to do is click login with redirect. So you click login with redirect and it will handle that for you. We also have login with pop-up if you want to, so you can have a pop-up, enter your credentials, and not leave your application. That is an option in our SDK, but the recommended approach is to redirect. You can use both. You can use either of those if you want to. And a way to log out if you need to. Those are the most important parts to configure the SDK. But the actual configuring is happening in the module, as I showed you, and it's actually pretty straightforward, a few properties and the interceptor. So now, to show you where you get these properties from, I will go to the Auth0 dashboard. Oh, I don't need StreamYard here. I will go to the Auth0 dashboard. If you have an account with Auth0, we have a free tier. You can get up to 7,000 active users for free. So,
could you bump up the font a little bit?
Oh, wrong window. Yes.
Yeah, that's correct. Good. Thank you.
So I have a few applications already configured, but that probably doesn't mean a lot to you. So I'm going to create a new application for just showing and reconfiguring the application and showing that everything works. So I'm going to call it Angular Dutch Group, ADG. I can choose if it's a native, single page, regular web app, or machine-to-machine application. Whatever we select here basically configures the flows that we are going to use automatically for us. We use a single page application, so I specified single page application. I click create, and that's basically all I have to do. And now I have my settings. I have my domain. There's nothing secret about domain. This is my domain. And I have my client ID. Those are the two values that I need in my application. So I'm going to use my client ID. I'm going to paste it in here for now. Right, this is my new client ID. I have a client secret. I don't need that, right? No secrets in a single page application. There are a lot of settings that you can configure. The idea of this talk is not to explain this entire dashboard, but the things that we need. One of them is the allowed callback URLs. So the redirect URL that you need, you are not allowed to redirect to any random URL. You need to configure the URL you want to redirect to, which is in this case 1,200. Right? This is the redirect URL that I want to redirect to, and only this URL is allowed as part of the redirect URI argument. And of course, also a logout URL. There's also a redirect URL that the authorization server redirects to when logging out. Same concept here. That's all we need to do. There are a lot of other settings, such as rotating refresh tokens, expiration on refresh tokens. You can mess around with all of those. But if I save my changes now, my application is actually ready to be used with a new client ID. So as you can see now, oh yeah, probably because I have an access token already. Did I misconfigure something? Probably. What did I misconfigure?
Should you change the domain in your application, in your SPA?
My domain is fine. My domain is the same.
Okay. Okay.
No worries. I know we were going over time, but I'm close to the end, so bear with me.
Okay.
and we will.
Yeah, sure.
Honestly, Frederik, I don't think people watching care really much how long we go. They are so interested in this topic, man.
Yeah, this topic
let's
is.
Go for another,
Keep it
let's go
going.
for another hour.
Actually, I'm game, so let's do it. Yeah.
I'm going to try adding a slash. Shouldn't matter, but hey, I'm down to trying everything today. I'm going for a few seconds. I'm going to lower the font so that I can follow along a bit easier. My thing is spinning, which is not supposed to happen. There isn't even a call happening. Wait, what's happening?
Wouldn't be a live demo without something like this, right?
Oh.
So I get a 400. My directory. Did I enable refresh tokens? Yes. I'm going to try this first before explaining. This shouldn't be the case. This is fun, right? If stuff don't work.
Yeah, probably it's something simple.
It's half the fun when you're doing live demos.
Yes, give me a second.
Sure thing. In the meanwhile, could we perhaps jump to maybe 1 or 2 questions as we're figuring this out? Is that something we can do, Jeffrey?
Sure, I think we can. Let me see, because I think you had a lot of questions.
Well, of course I did. Of course I did. It's more people than me that had a couple of
I'm looking,
questions in chat. Chat's been pretty busy, so.
Give me a sec.
All right.
Maybe we can put this one on. Is the expiration typically encoded within the access token? Why is the expiration stored outside of, in this case?
The expiration is inside of the token as well. I think it's just a matter of making it easier for us to parse.
Right.
But there's also the concept. So an access. So this is what I'm talking about, the refresh token. An access token should actually be treated as opaque. So in a single page application, we issue JWTs, JSON Web Tokens. So they have a specified format, and there's a validity or an expiration inside of it. But an access token, depending on what kind of application you have, is actually sometimes just a random string, which you cannot parse or read any info from it. And then there is no expiration in it. So that's why for the access token, we need it separately, even though it's also part of the access token when it's a JSON Web Token.
That's a great explanation, actually. Yeah, because it's embedded within there, but making the browser decode that JWT just to read it, why not send it along, right? It's the same data, right? So.
Exactly. So for the access token, the client should always think or treat them as opaque. So not try to parse.
Yeah, that's a good point. That was a good question, though, Joris.
Yeah.
That's a good question, for sure, yeah. Oh, looks like a server's down. Is there a Google outing again, man?
That would be fun.
Fun, yes.
Looks like a server's down.
Yeah. Yeah, I'm going to try that.
In there.
I'm going to try that.
You have clean storage left.
Yeah, there's a button.
It's on the laptop. Yeah. Just press it. Go.
Yeah.
Do it.
Okay,
do it.
You can do it.
It's fun. It's fun because it just worked with my old client ID. So let me use my new one again. So ADG.
That's a good question, Michiel. We'll get to that in a second, I guess. Let him do his magic, okay?
Don't you need to update the
domain
URL,
is my account,
domain too?
And I can have multiple applications in my domain, so that should not be changed. So now I am in my application, and I'm logging in. So we are getting there. As you can see now, it's asking for consent again because I haven't given consent to this application yet, right? So again, I have to accept it, and hallelujah, I'm back in my application, right?
Magic jazz hands in chat, please.
So the last thing I changed, but that shouldn't matter. So probably there was something else wrong. I added my domain to the core stuff as a allowed origin, but it's a redirect. It's not a post request, so that shouldn't matter in this call. So I'm not sure what was wrong. I didn't really change anything, but it works now. And now it doesn't. It's just
probably something just misconfigured, and you can figure it out later and put the example online.
Well, the example is our. It's funny. Is our normal official sample application. So it's supposed to behave properly, if used properly, I guess. I'm probably messing with it too much. But in general, this is the dashboard. This is the application that I created, a single page application. One thing I wanted to show in the dashboard as well is we have APIs that you need to configure, because my API is running locally, of course, but my API has to be registered in my identity provider in Auth0 as well. And then I get an identifier is what it's called here, and that's the audience. And then Auth0 knows that I'm trying to access this system. And my API that I'm running locally also has this audience configured, and then it can validate the token to ensure that it's the same audience. And that's how those two work. So if you have an API, register them in the APIs in Auth0, which is, you also don't need a lot of settings on those, because an API doesn't do much other than validating the token. The applications have a lot more settings to them. There are a lot of settings, advanced settings. There are grant types that you can enable, refresh token, authorization code, implicit if you need it. There are a lot of settings to do, but the main thing you need to get started in normal situations, it should work, is creating the application using the client ID, the domain, and specifying the callback URL and the allowed logout URL. And then everything should work as expected. So, yeah. As you see, it works, but there is something going on. But that's mainly the things I wanted to show, the different calls that are happening, the way how you integrate it, the way you can create apps and APIs in Auth0, and of course, the overview of OAuth itself. So I'm happy, excited for Joris's question.
Sure. Let me see. I think Michiel had a. Can I put your screen down? Is that good?
Yeah, just to clarify, that's the end of the presentation?
Yes.
Thank you so much.
Yeah.
No worries. Just want to mention one thing. If I refresh now, it works again. So I'm not sure.
Yeah, exactly. I understand you're still stuck a little bit on the demo, because it's so annoying when something doesn't work, when it worked all day, you know? So it's so annoying.
Yep, I won't sleep, but hey, no worries.
Exactly.
Okay, let me put your screen down. So Michiel Kikker, he's one of our truest followers there. He had a question in the redirect back to the app. Is it using code is that configurable?
I don't think it's configurable.
I think it was something like in the OAuth spec, right? That it's configured there, and it should do these kinds of stuff in the query parameters. And
it's in the OAuth 2, yeah. It's in OAuth 2. Unfortunately, because I would like to be at configurable too as well, yeah.
It's important, maybe something to add to the question as well, is sometimes it conflicts with other providers. So if you're like combining your application Auth0 with calls to LinkedIn, right? A direct calls to LinkedIn API, and they also use OAuth, they also use code. Then it's important to use different callback or redirect URLs for both identity provider. Then if you specify, let's call, say, localhost port 4200/Auth0, that's the callback for Auth0. Auth0 will redirect back to that callback, and our SDK will only parse the code for that URL.
That's a really good point, actually, because exactly when you're using, you could probably use LinkedIn through Auth0, right?
You can, but it's a little bit more complicated if you want to start querying their API.
Right. All right. Yeah. So, yeah. Okay. Fair enough. Yeah.
So, and I saw other question by Joris. Would the iframe approach also be problematic in scenarios when running a web application in the context of, say, Cordova? I'm experienced this adds additional restrictions.
I have never used Cordova. It sounds like it can add extra restrictions for sure. As I said, iframe is our default approach currently, but personally, I prefer using refresh tokens. Same for Cordova. It's also a client-side application, so you have the same kind of flow you have there. Our SDK that I've showed here is our Angular SDK, which is actually a thin wrapper around our single-page application SDK. So all the logic is in that SDK. So our React SDK, for example, uses also the single-page application SDK. But for Cordova, we have another SDK. So I think they don't even use an iframe approach. So if you're using Cordova, I don't think you want to use the same SDK.
Isn't that more of a native app versus a web app like approach difference in that sense? Because the iframe is a very, very different approach from, like, if you're using Electron, you might run into the same issue, I guess. So.
Yes, and using iframe, I'm not familiar with Electron, but using iframes in Electron also sounds complicated. Not sure impossible, but complicated. In a browser, it's pretty straightforward by injecting it in your HTML, listening to some events, and it works. So I think the fact between native and browser is definitely something that makes the iframe less interesting for native applications.
Where do you think we're heading? Like, the iframe might be on its way out. Like, if the web moves away from iframes, where do you think we're heading? Is that like underwater JavaScript fetch calls? Are we moving to something else? What are your thoughts on that?
I think we are moving to refresh tokens, rotating ones, of course. There are a lot of IDPs that support rotating refresh tokens. Once you support those, it is more secure. I think there are also some things happening around OAuth 2.1, which is all a little bit draft still, but where they are trying to implement PKCE everywhere. So everywhere where they can, of course, not everywhere, but server-side web apps that use the first flow that I mentioned will probably, when OAuth 2.1 is out, also use PKCE, which doesn't change anything about iframe or refresh tokens. But I think browsers like Chrome will start blocking these iframe approaches as well.
Just like
Safari does, and we will have to end up using refresh tokens or redirects the way I mentioned without using local storage and refresh token and just refresh your application. But yeah, eventually we'll probably end up using refresh tokens.
You think the Auth0 SDK, like the Auth0 package, as you deliver it right now for both Angular, React, and any application you might want to use it, will they be able to fix this problem in a way? Like if it's iframes or not underwater, whatever, like will they be able to fix this problem going forward? Or is this a problem that you have to fix in your own application yourself?
What problem do you mean?
The refresh token part, like where your identity isn't, when you come back after refresh, where your identity hasn't been set yet.
That's something you have to solve in your application through our SDK. Our SDK solves that for you if you configure it. We decided to be secure by default, so not using local storage and things like that, but it's just a flag that you set and you have local storage that you're using and you remember your refresh token. So our SDK solves that for you, but yes, your application has to tell our SDK that you want to do that you want to use local storage.
Okay, great.
Frederik.
So, go ahead, Sander. No, go ahead.
First, thank you for your talk. It was very inspiring. Having built authentication from the ground up for myself a couple of times, I know the amount of work they have done. So,
yes,
it's a lot of work. It's now so much simpler than it ever was, and it still isn't simple.
It's very complicated, and using our SDK is fairly straightforward, but the concept itself is complex, and even using our SDK can, there are trade-offs you have to take, as I mentioned, like storing it where you want to store it, should the user log in again, how long, should the refresh tokens be valid? There are so much questions that you have to answer for yourself.
Yeah.
Absolutely.
That make it complicated to reason about.
using local storage is a bad idea overall for any form of security thing. It's not suited for security at all.
Correct. But yeah, again, at sometimes you have to make trade-offs, right? I mean,
Of course,
if you cannot rely on cookies and you want to remember your refresh token, you have to store it somewhere. And it's important to realize that it's not necessarily secure, but if it's rotating, it is acceptable. If it's non-rotating, I would say it's not acceptable. But yes, local storage is not secure because you can access it anytime.
The web isn't secure by default.
Well, that's our job, right? To make it a little bit more safe for everybody.
That's why we organized this.
Exactly. Share information. No, everybody knows.
Try to avoid XSS is an important part.
Exactly.
Yeah, there are so many attack vectors that it's not funny anymore. If you connect to the web, your application is insecure and you have to deal with it.
Yes.
Authentication and authorization help you a bit, but don't be fooled. It will never be 100% secure. You can come like 80%, but if someone wants to get in, they are going to get in.
Yeah, we can try to make it as hard as possible. For example, with refresh tokens, internally, we use a web worker. We store everything in a web worker, so we make it very hard. Not everything, the refresh token, we make it very hard. If you use in-memory, of course, not local store. If you use in-memory, everything is inside the web worker, so it's harder for anyone to access the refresh token if they want to steal it. Only if you keep stuff in memory. Once you go to local storage, let's go.
Yeah, see our viewers like your talk, so we're getting some comments that people learning things. Let me saw another one. Michiel even wants to continue. Just go on.
Well, we've been going for pretty long so far, and I called them out on it. But so
we have a React SDK. I can move to that.
Well, maybe
different time. Maybe different time.
Yeah, different time. Next year, we'll come back next year. We'll do some React. Are the slides available later? Where can people find it? Are you going to Twitter them?
I will make them available. I will have to figure out how. It's PowerPoint, not always the most sexy thing.
Oh, we'll figure it out.
I will make them available for sure. The demo, if you want to, is available on our. I will tweet the link well, but it's available on our Auth0-samples organization, and that's one Angular samples repo that you can have a look at. It's the exact same sample.
Awesome.
That I demonstrated.
Awesome. So everybody can just go out, create a little bit dashboard within the Auth0 dashboard, and replicate that demo you just did.
Exactly, and hopefully it works from the first time.
Beautiful. So go out and do that.
Okay.
Frederik, can I share the links for our viewers in the chat so that they can sign up on the form, the feedback form?
Yes. So don't forget to enter the feedback form. Then you can choose whether you want a t-shirt or a coffee mug. Don't be surprised. So the feedback form just asks for your feedback and your email, and I think
maybe a t-shirt size.
T-shirt size as well. But what I was about to say is you will get an email to your email address that you entered with information for the t-shirt and the coffee mug. It might take a week or two because we will keep the form open for 1 or 2 weeks for people that will look on YouTube as well. And once we close the form, we will send out emails to an application where you can pick your own swag you want, the t-shirt size, probably enter your address, and it will be shipped.
Thank you so much for that. Thank you, Auth0, for doing this for us.
So cool, yeah.
So I think we only have one thing, but Sander, you want to ask a question, right?
Yeah. Can you repeat what is the amount of free logins you're getting in the free tier?
Should be 7,000, but I am Googling that for you so that I don't lie on a recorded session.
Is that 7,000 single signups, or is that 7,000 users
active users? 7,000 active
users.
Yes.
That's very interesting.
You want me to share your screen, Frederik?
Yes. Oh, I'm yes. Oh, yeah. Sorry, I was looking for the share.
No, I can still share it.
So the pricing mentioned up to 7,000 external, whatever MAU means, but the pricing page has been changed. It used to mention active users.
Well, MAU probably means monthly active users. So yeah, probably. Yeah, probably.
Thanks for that. The thing is, there are, of course, trade-offs to the free plan, like social connections. If you want to connect to enterprise stuff like Azure AD or anything, Active Directory on Azure, yeah, those are not part of the free plan. But you have 2 social connections that are part of the free plan. You have the SDKs. You can use up to 2 rules. I haven't mentioned about rules, but rules are comparable to middleware we have in Node and stuff like that, where you can have intercept the authorization request or the token exchange request. You can have up to 3 rules in the free plan. So there are limitations, but if it's just for yourself, the free plan is more than enough. And even for small startups, the free plan can be sufficient as well.
So, like say I want to use Discord and Twitter, that's fine with the free plan up to 7,000 monthly users?
I think the free social connections are limited to specifically Google and
okay.
I don't know by heart. I don't have a free plan.
That's right.
Yeah,
That's
but,
right.
But
yeah.
it's all on the
It's
on
on the
page.
website.
Oh,
yeah, exactly.
But don't be afraid to just mess around with
And 7,000 users is a lot. So
yeah,
cool.
Did that answer your question, Sander?
That answered my question. Yes, thank you.
Good. So I think Bjorn, you have selected 2 people out of our audience, and I will put the first one up. Let me see, because I need to scroll because he's in the chat. Let me give him. So Yannick, if you're still there, Bjorn selected you for one of our licenses of the Quokka software. So get in touch with us. You can do that or send a tweet to us. To one of the panelists, or go to Angular Dutch and send us a DM. And for the second one, let me look where it is. Let me put it up. I think it was Lara, if I'm correctly.
That's confirmed.
Also for you, just send us a DM via Twitter or to the Angular Dutch or one of the panelists, and we will provide you the license so that you can use it and play around with it. So I think that's a wrap. Frederik, thank you very much for being here. We would love to have you. Next year we will have you, but then for React probably.
That's fine. Thanks for having me, for sure. I mean,
yeah, of course.
It's the first time I gave this talk, as you noticed from the demo, but it's been fun to give it. So
awesome.
Yeah, but it was awesome, and authorization is always a hard thing. And you guys with your SDK, you make it so simple, basically.
That's what we try.
Yeah. So thank you, viewers. Thank you. Happy holidays if you're going for holidays. Happy Christmas already. Be safe, and you will see us next year again. Bye-bye.